So, a student hypothesizes that water from infrequently used school faucets contains more chemical impurities than the water from frequently used school faucets. What you need to understand right now is what the student guesses. His educated guess is that water from a school faucet that's not used very often is going to be a dirtier, more impure water than water from a faucet that gets used all the time. So, at the same time of day, the student uses the same water test kit to measure the water impurities from different faucets. Which is the manipulated variable in this investigation? So make sure you understand what he's looking for. He's checking this faucet right here that's used all the time to see if the water's cleaner. Or this faucet over here that's used very infrequently or rarely. Will this one be dirtier? That's his theory. It doesn't matter what the answer is because the question just wants you to know what the manipulated variable. Is it the chemicals used to test the water? No, because he uses the same water test kit. Is it the amount of water per sample? No. Is it the time of day when water is collected? That was never mentioned as a part of his hypothesis. Is it the location of the water collection? The answer is yes. He wants to know which of these faucets is going to be the dirty one. So the answer is D. This question is just about reading the chart and understanding what the y and the x-axis are. First, look at our y-axis as a measure of the air pressure in pascals. But look at the trick here. The trick is that they're going to give you 20,000 pascals, but down here they're going to ask you kPa, kilopascals. So just remember, a kilo means 1,000. So 40 kilopascals means 40,000 pascals. Same thing with meters on the x-axis. The meters is going to be given to you like, for example, 6,000 meters is right here on the chart. But in the question, it's going to give it to you as 6.0 kilometers. Once you realize the trick that they're trying to do here, the question's pretty easy. At which range of altitude is air pressure closest to 40 kilopascals? And if you find on the y-axis 40,000 pascals, which is the same as 40 kilopascals, and you head over, you find out that it's right here. And if you go down to your x-axis, you can see that it's in between 6,000 meters and 7,500 meters. So when we look at our choices, we can see that it's not A, but B is the correct answer because it's between 6.0 kilometers and 7.5 meters. So the answer is B. So a student hypothesizes that a sample of rock formed from ocean sediments. What would be a good clue that this rock was formed from ocean sediments, like particles from the ocean or pieces from the ocean, or came from the ocean? So what would best help the students support this hypothesis? A textbook about rock formation methods? That could help, but is it the best answer? Rock samples from several locations on the Earth? Possibly helpful, but check to see if it's the best answer. A model of the different crustal plate boundaries? Probably not. Clamshells found within the rock sample? If you look over here and you were to see this rock and you saw all these clams, would you think that was formed in the ocean? Probably true. So I think D here is the best answer. Students plan to use several rain gauges to compare average monthly rainfall of Virginia's coastal plain and Piedmont regions. Which of these variables should be manipulated? All right, a lot goes into this question. The first one is you have to know what a rain gauge is. And if you look here at the picture, a rain gauge is a simple device that you put outside, and it has some markings here. Usually, like here, we have milliliters, and it will tell you how much it has rained. Second, you need to know what Virginia's coastal plain and Piedmont region is. We live here in the coastal plain. And the Piedmont region kind of begins right around Richmond at an area called the fall line, where we see a significant drop in elevation to a flattened coastal plain. All right, so what's important? to find out how much rain there is in the Piedmont region versus the coastal plain? Is it the height of the gauge? No, that's not what's important. What about the brand of the gauge? Does it matter if it's a Nike gauge or a Adidas gauge? No, not at all. The size of the gauge? No, as long as they're all consistent, that's not the most important. What about the location of the gauge? If you want to find out where it rains the most in these two different regions, you have to have them in different locations. So the best answer here is D, location. A student claims that the full moon, as you can see here, occurs about once a month. What process will verify or substantiate or make true the student's claim? Hypothesizing, just making an educated guess about it, theorizing, predicting, or observing. Which one of these four things can make it clear that once a month there's a full moon normally? And the best answer here is J, observing. Alright, let's look a little bit about our scientific process. It begins with you asking a question, having a question about the world around you. Then you should do some background research. And at this point, you'd like to construct a hypothesis or an idea or an educated guess about what you think will happen. Then you test with experimentation. And then you should analyze your data, draw conclusions, and then finally, communicate your results in like a professional science journal. This question puts things a little bit easier. It's just asking you to put these in order. Propose an outcome, state the problem, make a conclusion, or gather data. Well, we know for sure make a conclusion is going to be last. Alright? And before you can propose an outcome or gather data, you have to state the problem. So we want to state the problem first, propose an outcome, gather some data, and then make a conclusion. So our best answer here is going to be H, which would be state the problem, propose an outcome, gather data, and make a conclusion. H. Alright, this is just a reading the chart question and basically completing the chart. Based on the above symbols, which of the following represents a wind speed of 30 knots? We see just a standard line here is, winds less than 5 miles per hour. And then once we get one little half line, we're around the 5 mile an hour range. A full line, we're around the 10 mile an hour range. And these basically are counting up by 5, as you can kind of see here. So it's asking you for 30, which we know we'd basically just have to draw a box right here and make this half line a full line. And that would represent 30 knots. So our answer is A. When you read this question, you may think this is a very difficult geology question, but in disguise, it's really just a question if you can interpret the picture. Alright. The map shows the ages of the exposed bedrock in Virginia. Which city sits on exposed bedrock that is the same age as the rock in Bristol? First of all, this picture really doesn't tell you anything about how old these rocks are. What it does tell you is which two cities are sitting on the exact same rock, so therefore they are the same age. And if you look, Bristol is sitting on this kind of light gray with little round dots, speckles on it, and so is Harrisonburg. So if you look real close, they're sitting on the same rock, so therefore they're the same age. So our best answer here is G, Harrisonburg. It's a tricky question. In the late 1920s, Edwin Hubble discovered that the galaxies are moving away from each other. He used this chart right here, distance in light years for your x-axis and velocity in your y-axis, to determine the expansion rate. Alright, what is he able to calculate? Now this is simply a math question. It is not really an astronomy question. It is just seeing if you know how to find a ratio. And remember, a ratio is that rise over run. So if you have a dot here, it's 1 divided by 2. So your slope would be 1/2. And if you look right here, it's going to be 6 over 6. In fact, here it would be 6 divided by 6. Your slope would be 1. So all you have to do on this chart right here is pick 2 points and do the dividing. Alright, so if we do 500 divided by 3, or if we did like 1,000 divided by 6, either way, we would find the closest answer we would find would be A, 150 kilometers per second per 1 million light years. So this is just a math question if you can read the chart and find a ratio. Alright, so if you actually found something like 166 kilometers per 1 million light years per second, then you have to pick the answer that's the closest to that. Okay, this question you first have to kind of know what a watershed is. A watershed is an area that's kind of usually surrounded by mountainous area where everywhere it rains in this area, eventually that rain goes down the hill and enters a little stream, and eventually the little streams come together and form larger streams, and then these streams lead to rivers, which eventually usually drains into an estuary or a Great Lake or an ocean. Now, so a watershed is an area where every drop of water in this area eventually drains into one certain river. Now, according to the above map, the largest river basin in Virginia is drained by the... Now, really what this question also can be answered is, which one is the largest? And if you look through here, in Virginia, the James River Basin is the largest. And the James River Basin is for the James River. H is the best answer. This question is a puzzle. It's kind of like finding the DNA of a star. So if you know what DNA is, it's like a way to tell who did the crime by looking at a blood sample, or who somebody's parents are, or things like that. So every star has a very specific spectral of certain elements. And this is mystery star right here, spectrum of star X. And if we look at star X, we've got 2 close lines here, and we've got a big space here, an even larger space here, and then another large space. Now, here's calcium, sodium, neon, and mercury. So basically it's asking you which is star X, which one of these? And if you look, we see that it doesn't really match up with mercury, doesn't match up with neon, definitely doesn't match up with sodium. There's no long space here. But if you look at calcium, look here, we got 1 line, 2 lines, like right here. We've got a big space, then we got 2 close lines, big space, and then another little square. So this star has a lot of calcium. So which of these elements does this star contain? And the answer is B, calcium. You are going to see a question on the SOL that has to do with why life on Earth is doing so well. And the answer is always going to be oxygen or water. Alright, so when you read these questions, please don't overthink them. Alright, let's just look here real quick. Because of its unique position of the Earth in the solar system, life has flourished. To flourish would be like these trees here blooming, doing really well, due to the presence of helium, volcanoes, maybe very indirectly, but don't overthink these. Liquid water or salt have to have water. Alright, so our best answer here is C, liquid water. Alright, 99.7% of all water on the earth is found in the oceans. Can't drink that water. The seas, can't drink that. Ice, can't drink that. And the atmosphere, can't drink that. Based on this information, which statement is most accurate? Alright, the Earth's fresh water supply is infinite or unlimited, and we have as much as we could ever need. That's not what that statement was about. Less than 0.3% of the Earth's water is drinkable. It did imply that because it said 99.7 is in all these places, and those are not drinkable water. Alright, let's look at the other ones. Humans are not dependent on ocean water. we are dependent on the oceans, just not to drink the ocean water. So be careful of that one. The water cycle returns all usable water to the sea. That's not what the water cycle means. So our best answer here is less than 0.3% of the Earth's water is drinkable. B. Our compass rose, we've got north, east, south, and west, and in between north and east, we've got northeast, and southeast, southwest, northwest. And in between north and northeast, if we were going right up this direction, we would be going north-northeast. If we were just a little bit below northeast, we would be going east-northeast. All right, in what direction is Staunton, right here, Staunton, from Richmond? So Staunton from Richmond. So in order to get to Staunton from Richmond, we would have to go this direction. Should be the same as this direction. So our best answer here is B, northwest. This question looks like it might be difficult, but they give you an easy way out. All right, so there's a hard way and there's an easy way to get this question right. Let's look at both. The hard way would be, let's look at the question. The mineral in the above table that has a blue color and will scratch garnet. All right, so let's find garnet. Garnet has a hardness of 7.5. All right, that puts it right here between quartz and topaz on the Mohs hardness scale. So, because garnet is in between quartz and topaz, it's harder than quartz. So it will scratch quartz. But because topaz is an 8, that means it's harder than garnet. Topaz will scratch garnet. And that's also given to you right here. Topaz is an 8. So our answer is D, topaz. But let's look at the easy way you could have gotten this right. The mineral in the above table that has a blue color. Well, garnet is yellow, red, green, and black. Magnetite is black. Pyrite, fool's gold, looks a little gold. Light brassy yellow, or a little bit gold. Topaz is colorless. Well, that's not blue. And various colors, meaning many colors. So one of those colors could be blue. So our answer is topaz, whether you looked at it the hard way or the easy way. D, topaz. This is an easy question. Syenite, which is Al2SiO5, quartz, which is SiO2, and leucite, which is KAlSi2O6. May be grouped together because they all contain, what do they all have in common? Well, they all have oxygen in common. Let's check. Aluminum, carbon, potassium, silicon, so that's not it. Do they all have aluminum in common? No, quartz has no aluminum. Do they all have potassium in common? No, only leucite has potassium, and none of them have carbon. So our best answer here is silicon, because all three of them have Si for silicon. Which of the following is part of a valid process, meaning a good process, a true process for supporting a hypothesis? So if you have a hypothesis, all right, how do you support it? In a valid method. Test with an experiment, that's good. Analyze your data, communicate your results. All those things are good. What about altering your results or changing them to get the answer that you want? That's not valid. Single trials, doing an experiment one time, not troubleshooting and checking your procedure and redoing your experiment to make sure, that's not good. Experimentation is absolutely a part of valid science and a valid process for supporting a hypothesis. Limited research. Sometimes this one tricks kids and makes you pick D because you see the word research, because research is important. But when they add the word limited, that means like minimal or not enough. Limited research. So our best answer here is C, experimentation. All right, we have a nice graph of a hot day, July 15th. And we see that in the middle of the night our temperatures get really low, and then as the sun comes out around 6 in the morning, it slowly gets warmer and warmer and warmer, and normally it reaches its peak temperature in the afternoon by about 3 o'clock as the ground reaches its maximum heating. And then we see it's starting to cool and cool and cool. But on this day at 2 p.m., all of a sudden the temperature dropped dramatically, and then it got warm again. What maybe cooled the temperature off at 2 p.m. so dramatically in such a quick period of time? Would it have been daylight savings time? No, that's ridiculous for so many reasons that I don't want to even waste any time talking about it. An eclipse of the moon. Now, sometimes kids pick this because they get confused between an eclipse of the moon and an eclipse of the sun. I understand what you're thinking, that if there was an eclipse of the sun and the sun was blocked out, that all of a sudden the temperature would drop. But first of all, that's not what this is. An eclipse of the moon is when the moon gets blocked out by the Earth's shadow, which would have nothing to do with the temperature on the Earth. A solar storm. So if we had a big storm from the sun that rained down on us, I think it would be very unlikely the temperature would drop. In fact, if something that bad happened, maybe the temperature would actually increase. A thunderstorm passed? Could it be that simple? Could it just be because it rained? Yes, that's the answer. That would be why it would cool off in the afternoon in July, because it rained. We see a chart here that tells us about a chondrite, the minerals that make it up, and an achondrite, the minerals that make that up. Now we notice that both have a lot of pyroxene, but a chondrite contains a lot of olivine. Right? They both have some feldspar. They both have some, well, this one has some nickel, this one doesn't. All right, so let's just find out about the question. Most meteorites that fall to Earth are either chondrites or achondrites. The chart above shows the composition of these meteorites. Based on these charts, which is a valid conclusion? So which one of these statements are true? Both types are predominantly pyroxene. Well, an achondrite is definitely predominantly pyroxene, but a chondrite would be predominantly olivine. G, both types are predominantly olivine. Well, we know that achondrites are predominantly pyroxene, so that one's out as well. So you can cross off F and G. Achondrites contain more feldspar. Achondrites contain 21% feldspar, and a chondrite contains, let's follow the bar up, just a little above 10, so like 11 or 12% feldspar. So H is true, and it is supported by the chart, so our best answer here is H. According to the map, the mean annual temperature, and remember the mean is similar to the average, all right, for most of the eastern half of Virginia is between, well, we just want to find Virginia, and here the majority of the eastern half of Virginia is in between the 55 and the 60 degree temperature. So our best answer here is H. 55 and 60 degrees Fahrenheit is the mean annual temperature for Virginia. This is a picture of a rock tumbler. You can put rocks in this and they'll roll around and they'll bang into each other, and eventually they'll get polished and smooth. All right? So the question here is, how much limestone was worn away between day 1 and day 2? So these are rocks and minerals in a tumbler. We have some quartz, we have granite, limestone, and sandstone. All these other lines are just here to confuse you because the question is about limestone. So how much limestone did we have on day 1? We follow the chart up, we find the solid black line, which is limestone. Looks like we had 2.8 grams of limestone in day 1. How much did we have at the end of day 2? We had, right here's day 2, we had 2.6. So how much was lost? If we started with 2.8 and we ended up with 2.6, our best answer here is A, 0.2 grams. Climbing Mount Everest is very difficult for so many reasons, but one of the biggest reasons is as you go higher in altitude and you climb to the top of the highest point on the Earth, you get less and less air pressure and less breathable oxygen. So this chart shows the relationship between altitude and pressure. And we can see that the pressure starting here at 1,000 millibars on the surface starts really dropping to the point where when you're at the top of Mount Everest, boy, you have very, very little breathable air. You're up there with the very, very tall clouds. All right. But the question just is, what is the approximate air pressure at an altitude of 22 kilometers? So kilometers is our y-axis. We just got to travel up until we find 22, and we see the answer is not much. Then we have to come down here, and it's in between 0 and 100, right? And there's only one possibility. That's in between 0 and 100 millibars of pressure. So our answer is F, 40 millibars. All right. According to the graph above, a piece of timber containing 1/8, here's our 1/8, look at our 1/8 right here, 1/8, of the amount of carbon-14 that is found in a living tree, died about how many years ago? So all you have to do is just read the chart. We go up and we find 1/8 of the amount of carbon-14 means that this tree died 17,100 years ago. So our answer is C, 17,100. The countries shown here released much more carbon dioxide than the rest of the world because these countries have the largest, so the United States released the most CO2, followed by Canada, Germany, the United Kingdom, Japan, France, and Italy. These countries are the biggest polluters of carbon dioxide because the number of people? No, there's a lot of countries that aren't on this list that have far, far more people than the United States. The amount of rainfall? That's not where carbon dioxide comes from. The number of heavy industries? Absolutely. The answer here is H.